Hey everyone, in this video we're going to be solving this Leetcode problem 46 permutations. Okay, so let's see what's the problem given to us. So it is said, given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. So we are essentially given an array of integers and we have to return the number of permutations, all the number of permutations possible for that array. So if we know, I guess we know permutations, and the way we can find permutations is by since there are three numbers in this array, so the number of permutations possible is 3 factorial. Okay, which is equals to 6. So there are 1 2 3 4 5 and 6. So there are 6 factorial 6 permutations possible. So for n number of integers there are n factorial number of permutations possible. Okay, so now that's out of the way. Let's try and solve this problem. This problem can be solved using recursive approach. Okay, we can solve this problem by recursive approach. So let's check out the algorithm of how we can solve this problem. Okay, so essentially we are given an array 1 2 3 of integers containing 1 2 3. Okay, so 1 2 and 3, we have 3 integers in our array. Okay, and for the permutations we can have, let's suppose we take 1. Okay, let's suppose we take 1 and in our answer array we have a 1. Now we can permute again for 2 and 3. Okay, again we can permute for 2 and 3. Now let's suppose we are taking for 2. Okay, so 1, so we would have 1 and 2 in our resultant array. Okay, and and we have a 3 in our nums array. Okay, now 2 is out of the way. We can permute for 3. Okay, so we would have 1 3 and in the nums array we would have a 2. Okay, we would have a 2. Okay, again since there is only one element left in the array, so we can have 1 2 and 3, and for this part we would have 1 3 and 2. Okay, now we can have the same decisive recursion tree for 2 also. Okay, so if we take 2 and we would have 1 and 3 in our original array. Okay, 1 and 3 in our original array. Again if we take 1, so 2 1, and in our array we would have only 3. Okay, original array. And again if we check for 3, okay, so we would have 2 and 3, and in our original array we would have 1. Okay, so since in this case only one element is left, we can have 2 1 3, and here we would have 2 3 and 1. Okay, so the 4 permutations are already here. Okay, let's see. 1 2 3 1 2 3 1 3 2 1 3 2 2 1 3 2 1 3 2 3 1 2 3 1 and 3 1 2 and 3 2 1 would be done if we take 3. Okay, if we take 3 we would have 3 1 2 and 3 2 1. Okay, I am not solving for 3. You get the idea. Okay, so so now this is out of the way. What we can do is this is all our answers, so we can return all of these answers in a list. Okay, in a list of arrays. Okay, and the way we can solve this problem is through recursion and using backtracking. Okay, so how we are using backtracking I will show you. let's write the code first. Okay, let's write the code first now. So we would have a list of integers, okay, where we would store all we would store our answer. Okay, integer list equals to new array list. Now we would have a function, backtracking function, which would add the elements into our temporary list. Okay, so sorry, okay, and at the end we can return list. Okay, and now we would have the backtracking function. Okay, backtrack list, let's copy paste list of integer, list of integer, list comma list of integer temp list and the nums array. Okay, and the nums array. Now what we are going to do is we will be essentially checking if the elements in our temporary list, the list in which we were adding the elements, okay, if that is equals to the size of the length of the array given to us. Why we are checking this? Because at the end you saw that we had 1 2 3. Okay, by the decisive tree we had a 1 2 3 in our answer array. Okay, in our temporary list we had an answer array. Okay, we had 3 elements, and these 3 elements are equals to the number of the elements we had in our nums array. Okay, that is why we are checking like this. And also another case is that since we have already iterated over all the elements in the array given to us, so there was no element in our original array, that is the nums array, so we cannot iterate through that part of the array. So that is why we are checking like this. Okay, I hope you get it. Okay, now what we are going to do is we will add the we would add the temporary list into our main answer list. Okay, new array list temporary list temp list. Okay, now comes the main function of the algorithm. Okay, so main part of the algorithm. So what we are going to do is essentially iterate over the array. Okay, and I'll show you. Wait, and iterate over the array, and if the template dot contains, if the list already contains the number currently I is at, if it already contains that, then we are going to continue, since it already exists in our template, so no need to do anything for that. Okay, now if it does not exist in the template, what we are going to do is add it into our temporary list. We are going to add the number into a temporary list, and then we are going to call the function backtrack on the next set of elements. Okay, we are going to call the function on the next set of elements, list, temp list, and nums. Okay, and at the end what we are going to do is pop off the last element added into our list from the pop of the last element added to a list. Okay, temporary list. So what we'll be doing is temp list dot remove temp list dot size -1. Why we are doing this? Because at the end, when we had 1 2 3 1 2 3 and again we had something like 1 3 2 1 3 2. Now by recursion, you know that recursions in the stack tree, when this function has no more decisions to make, it will go back the tree. Okay, so when it's going back to the tree, okay, and we did not had something like if I can write the decision tree again, the previous part, we had something like 1 2 and in the main array we had original array we had a 3. Okay, so now what we did was we added the 3 into our temporary list, and now no decision has to be made for this element, since the original array is empty, so no decision was to be made for this array. So for this array. Okay, so what would recursion do is it will backtrack to the previous function. Okay, and in the previous function we did not had this list. Okay, we did not had this array, we had this array. So that is why we are removing these 3 when we are backtracking to our previous function. I hope you get this point. I hope you get this line. Okay, it's very easy. And we are popping off this element, we are removing this element when we are backtracking to the previous function. Okay, now this is what the main gist of the problem is. Let's run the code and see if it submits. Okay, public. Okay, I forgot to add the void method. Cannot find remove symbol. Okay, made a mistake. Let's run. Okay, it runs. Let's submit. Okay, it's accepted and it submits, and it's kind of good solution. It is a good solution. The time complexity for this solution is O of n into n factorial. Yes, n into n factorial. So this is what we are going. This is what the submission is and the time complexity is. If you like the video, please give it a thumbs up and subscribe to the channel, and I will see you in the next video. Bye.